Hello students, we are starting here our new topic, Topic 1 Linear Algebra, and we're going to start with 1.1, looking at what is a matrix and some different vocabulary of matrices, also multiplication, identity and zero, all of this sort of stuff. So let's start with defining all of those terms. So first of all, a matrix is just an array of numbers, and the plural is matrices. And normally we denote matrices with capital letters. So for example, I could have a matrix A, and let's say we've got 1, 5, negative 7, 2, 3, 1. So we've just got an array of numbers. Notice I have rows and columns. And so the order of a matrix, the order of this matrix, is 2 by 3. So order is rows by columns. Okay, two matrices are equal if they look exactly the same. So they have to have the same order, the same elements. We call these individual pieces elements. So to be equal, they have to be exactly the same. A zero matrix, well, that's full of zeros. It can be any size and is full of zeros, and we normally denote that just by writing a 0. Square matrices are matrices that have the same number of rows and columns. So this is a square matrix. This is a 2 by 2 square matrix, and specifically a square zero matrix. So any square matrix, same rows and columns. Identity matrices are always square. So I is an identity matrix. It's a square matrix with 1s on the major diagonal and 0s elsewhere. So our 2 by 2 identity matrix 1, 0, 0, 1, the 3 by 3 1, 0, 0, 0, 1, 0, 0, 0, 1, etc. For matrices, we can use either parentheses or we use brackets. Either one of those things is acceptable. Okay, a transpose matrix is where we switch the rows and the columns. So let's do A transpose. So we use an exponent of a capital T to denote transpose. So if this is my A transpose is going to be 1, 5, negative 7, 2, 3, 1. So notice the order of A transpose is a 3 by 2 matrix. So my order gets switched because my rows and columns get switched. Skew matrices. So we've got, symmetric and skew symmetric. So symmetric matrices are when A transpose is equal to A. So if we're switching our rows and columns, if these two things are going to be equal, then it has to be a square matrix. First of all, A must be square. And then also when we switch our rows and columns, the elements have to line up as well. Skew symmetric is when A transpose is equal to negative A. This means all of the elements of A have become negative. So if we look at negative A from our matrix up above, we would have negative 1, negative 5, positive 7, negative 2, negative 3, negative 1. So when we have a scalar on the outside, we just distribute that. And we're going to look at that in our next examples.